Hey y'all, in this problem I'm going to show you how to use vectors in order to calculate the net vector. In the previous video I showed you how to get the components. If you have the net, this one is going to be the opposite of that. So one 360-degree clockwise revolution of one of the two dials on an Etch-a-Sketch results in a horizontal heading to the right or vertical heading to the top line of 3.0 inches. An artist turns both dials clockwise simultaneously with the same speed of 60 degrees per second. What is the magnitude in inches per second and direction of the velocity of the marker on the screen during this time? So just like with the last one on the previous video, I need to make sure that I have the correct unit first before I can draw my diagram. Because I know that I'm trying to find the velocity, that's where I need to start. Now here I have a velocity. It's telling me it's 60 degrees per second for the speed. However, it wants it in inches per second and it gives it to me in degrees per second. So that's the first thing that we need to fix. So if you have 60 degrees per second, you can put 1 second here, or you can just put second. I still need it in per second, but I need it in inches instead of degrees. The conversion that I'm going to use for this was the fact that it told me that for every 360 degrees, that equates to 3.0 inches. So degrees is on the top, which means I need degrees on the bottom of the next one. That's going to be the 360. And the number of inches that's equivalent to a 360-degree revolution is 3.0 inches. The degrees will cancel on this, and then I'll be left with inches per second for my unit. Put that in the calculator. You're going to end up with 0.5 inches per second. Okay, that's the first part. Now, I can go ahead and draw this diagram because I know that this is the velocity for both of the lines. Remember, I'm turning two dials, one that's horizontal and one that's vertical. So my diagram will look like this. Horizontal, vertical. They both have the same speed. I'm turning them simultaneously at the same speed. So both of these are 0.5 inches per second. This is the one that I'm trying to find here, the resultant vector. In order to do that, I can use Pythagorean theorem because I have a right angle here, which means that this is a right triangle, and I have the two sides, so I can use a squared plus b squared equals c squared. Or if you're fortunate enough to have remembered your 45, 45, 90 rules for special right triangles, then go ahead and use that and skip this step. If you do know those, you know that this is x and x are these two sides, then this is x square root of 2. So I could just say 0.5 square root of 2. Put that in the calculator, and that will give us the magnitude of this. Okay, if that's way over your head, that's totally okay. Use Pythagorean theorem. You'll still get the same answer. 0.5 squared plus 0.5 squared equals c squared. Okay, so I'm going to break this down step by step. 0.5 squared plus 0.5 squared equals 0.5. C squared. Take the square root. C equals 0.7071. Okay, I'm going to leave some extra things on here for now just to show you this, since I just wrote it what C was equal to. But since that is what I'm trying to find, I'm going to label this correctly. This is a velocity. and it's the vector. So now I'm going to write it using this notation, and I'm going to make sure that I round to the correct sig figs. Okay, I started off with 3.0 inches and 60 degrees inches. I'll do 2 sig figs for the 3.0 inches. So this would be 0.71 inches per second. Okay, you can either write the SEC or just the S. Either way is fine. Now the next thing that I need to do is make sure that I know the direction. Okay, this is the magnitude. The direction is going to be what this angle is. Remember that we do our angles above the horizontal typically, okay, or north of east or something similar to that. For this one, because I'm dealing with a horizontal and a vertical, I'm going to do above the horizontal. Again, going back to this 45, 45, 90, if you know that these two sides are the same, then you know that this is a 45, 45, 90 triangle. If you don't remember that, then you're going to do it this way. And this is the way that you can do it for all of them when it's not a special triangle. So this will help you regardless. In order to figure out what this angle is, you have the opposite side and the adjacent side. So we're going to use tangent. However, because I don't know what the angle is, I have to use the inverse of the tangent. You use regular tangent if you know the angle, and you would just put in your calculator tangent of whatever that angle is. But for this one, I don't know what this angle is. That's what I'm trying to find. So I use these two to put in my fraction. Opposite over adjacent. Again, for this one, it doesn't matter where they go because they're the same number, but remember, for other instances, it will be opposite over adjacent. Adjacent meaning right next to it or touching, and opposite meaning on the opposite side of the triangle. I'll show you how to put this in the calculator now. So this tangent inverse, if you look, it's right here. And in order to do it on this calculator, you would hit second and then tan, and then just put in your fraction, or you can do it as divided by, either way. Okay, and then there's that 45 degrees that we talked about. Now, don't just leave this like this and this. Okay, make sure that you are writing it out. So velocity 0.71 inches per second at 45 degrees above the horizontal. Hope that helps, guys.